architecture of 8085 microprocessor. Right? So what do you mean by a microprocessor? Like 8085. So it is an input microprocessor which is used to perform or used to compute any operations. Right? So the important blocks of this 8085 architecture, that is 8085 microprocessor, it contains a register block. So microprocessor 8085 has got different registers. We have W and Z, which we call as a temporary registers, and the register B, C, D, E, H, L, we call it as a general purpose registers. Apart from these registers, we have a 16-bit registers that we call as a stack pointer, program counter, then increment, decrement latch. So we have a question: why the stack pointer, why the program counter? So microprocessor execute the instruction one by one. So the program counter under increment and decrement address latch. So here the stack pointer will hold the address of the previous instruction executed, whereas your program counter will hold the address of the next instruction to be executed. Now microprocessor will have a bus, system bus. So there are three types of system bus. One, you have an address bus, data bus, and a control bus. Now we have an address latch enable which is used to demultiplex the multiplex address data bus. So we have an higher order data bus A8 to A50, and we have a multiplex address data bus A0 to A7. Then come to the block instruction registers. So we know that microprocessor will work based on the instruction what we give. So whatever the instruction we are writing as a program, that will be go to the instruction registers. So from the instruction registers, it will go to the instruction decoder, where it will decode the instruction or it will fetch the output. Then it will go for the machine cycle encoding, where it will decide how much time is required for executing an instruction. So now it will give the code to the timing and control unit, which will produce the necessary timing and control signal to execute it for the required instruction. Now the main important part, that is your ALU part. So ALU means arithmetic logic unit. So here we have an accumulator and a temporary register. So we know that accumulator is also a input register which is used to hold the data temporarily. So when you do an addition operation, one of the data will be present in the accumulator and the result is also stored in the accumulator. So accumulator is a temporary storage register which we call as an A registers. Then we have an ALU which performs the operation which is defined by the instruction. Then it will give to the data bus. Then we have one more registers which we call as a flag registers, or we call it as a program status code. The main purpose of this program status code or the flag register is to know the status of the instruction which we have executed, right? Okay. Now, when you come to the top blocks which we call as an interrupt blocks. So what do you mean by interrupts? Whenever we have a programs, the microprocessor will execute the instruction one by one. Suppose if you want to interrupt the processor to do any subprograms or subroutine programs, we have to use an interrupt controls. So the interrupt control has got 6 pins. One is your interrupt request, which we request the microprocessor that we are interrupting. So the microprocessor will acknowledge whether they can service the interrupt or not. So that can be determined by interrupt acknowledge symbol. Then we have a lot of interrupts, that is track, RST 5.5, 6.5 and 7.5. So out of which track has got the highest security. Then come to the other block, we have a serial input and output control block. So in a serial input and output control block, so whatever the data is available to from the microprocessor or through the microprocessor, that is carried to the help of the 8-bit right? So we have a different timing control signal strings in the timing and control unit. So X1 and X2 are called as a crystal output, which is used to produce the clock. So we have a clock generation and we have a clock mode. Then we have a ready and we have a read bar, write bar. So these bars will tell you whether the microprocessor is doing a read operation or write operation. Then S0 and S1 is going to determine the status. Status in the sense whether it will be in the input output operation or it will be in the memory operation. Then finally we have hold and hold acknowledge. So microprocessor will hold the program for some time and acknowledge. Similarly, the previous program can be resetted by the